Hi there, thanks for clicking on my video. My name's Kimberly and I'm a tutor here on Wyzant. I have a physics problem here that came up in one of my recent lessons that I thought was so interesting I made a video about it. So let's get right into it by reading the problem statement. We're asked to consider the two-body system depicted in figure 1. First, we have to determine the acceleration of the system as block B falls down, given a numerical value for the coefficient of kinetic friction, as well as the ramp incline and the mass of each block, which are the same. Then in part B, we're asked to find the minimum value of mu to prevent the system from accelerating, and we're told we can ignore the masses of the cord and the pulley while also ignoring friction in the pulley. So let's go forward and draw some free body diagrams. So first I'd like to talk about the free body diagram for mass B because it's much simpler. We have tension going up and weight going down. It's that easy. For part A, it's quite a bit more complicated. First, we have to adjust our coordinate axes so that the acceleration is entirely in one dimension. So to do this, we're just going to line up our x-axis with the ramp so that it's angled below the horizontal by theta. And then we have y perpendicular to that. So then we draw the free body diagram. Tension is in the minus x direction, friction is in the plus x direction, normal force is in the positive y direction, and weight is down, which ends up lying in both the x and y dimensions. And this is pretty simple because weight is our only force that lies in two dimensions, and the acceleration is all in one dimension. So that's as easy as it's going to get. And from here, we can create some systems of equations so that we can solve the problem and find the acceleration. So we're going to begin by recalling Newton's second law, F equals ma. There's three equations we can make from Newton's second law. First, by analyzing the forces on body A in the x direction, we have friction minus tension plus weight. So F minus T plus mg cosine 90 minus theta is equal to mass times acceleration. Then we do the same thing in the y direction. We have the normal minus the y component of the weight, which is mg sine 90 minus theta, equal to 0. Then we have the forces acting on body B, which is tension going up minus weight going down equals ma. Because the blocks have the same mass, we just use m for the mass every time. And because they're connected and there's no friction in the pulley, we can just use a for the acceleration because they have the same acceleration, even though it's going in a different direction. And it has the same magnitude, and that's what we're concerned with in these equations. Now for part 4, for a fourth equation, because we have 4 unknowns and only 3 equations, we have to use the definition of the coefficient of kinetic friction to finish the problem, to close our system. We have to just say mu equals F over n. Pretty straightforward. Now, from here, the physics is over. We're just going to do algebra to finish things up. So first, we're going to do some rearranging on equations 2, 3, and 4. So equation 2, n minus mg sine of 90 minus theta equals 0, becomes n equals mg cosine theta, because remember, sine of 90 minus theta is the same as cosine theta. For equation 3, we have t minus mg equals ma. We're just going to move the mg over, so we have t equals mg plus ma. Then for part 4, we had mu equals f over n, which tells us that f equals mu n. And since we knew from equation 2 that n is mg cosine theta, we know that f is mu mg cosine theta. So this is great. Now we can look at equation 1 and we can finish the problem. So here we just write down, using equations 2 and 4, we change f into the mu mg cosine theta as we discussed earlier. Then using equation 3, we turn t into mg minus ma. And using a trig ID, we turn the mg cosine 90 minus theta into mg sine theta, and that's all equal to ma. Now we have one equation and one unknown, so we can just go ahead, rearrange things, and then insert our numerical value and get that acceleration is equal to 1.6 meters per second squared. Finally, for part B, we're asked to determine the coefficient of friction such that there's no acceleration. This might sound confusing, but it's actually pretty simple. All it's saying is that now the coefficient of friction becomes an unknown, but a is equal to 0. So we just return to our final expression for a, change a into 0, and change mu into an unknown. Then we just solve for mu, and we find that mu equals 1 minus sine theta over cosine theta, and that's 0.53. Thank you for watching. That's how you solve the problem.